Welcome back. In this lesson, we're going to look at the second class of sedimentary rocks. We've looked at the detrital sedimentary rocks, which are pieces that have been glued together, cemented together. And in this one, we're going to look at the chemical sedimentary rock, in which ions or chemicals themselves have been dissolved out of the rock. So almost like a salt, that then as the water is removed, the salt remains on the bottom of the pan. So all kinds of different chemical rocks we can find. We can find rocks made out of calcium deposits left over from seashells. We can find other rocks that have leached out chemically as acids have chemically reacted with other stones. So as some rocks are broken down chemically, they can form other type of chemical sedimentary rocks. So let's look at some of the details. To understand chemical sedimentary rocks, you need to understand a tiny bit of chemistry. So a chemical, a lot of times we see it as some type of a product of a chemical reaction. And most of the time, in this case, when you're making minerals and those minerals are coming together, you have ions, which are charged particles. So you're going to have positive ions and negative ions that find each other just by attraction and then stick together by electric forces. So just like your socks stick together in the dryer. So if you can have a rock that has been weathered chemically and broken down into ions, and then those ions are in the water, then in the water you have dissolved essentially salts. You have dissolved salts. You have dissolved rocks that are in the water as ions. They're going to find each other and then settle out. So they settle out as a crystal. So essentially you're going to have something of a mineral. Much of the ones that you're going to see around us is limestone. So limestone is lots and lots of calcite. And calcite here at the bottom is calcium carbonate. Okay, calcium carbonate. So calcium is a metal. Carbonate is the negative. So CO3 is the negative. When it puts together, you're going to have these very, very fine rocks that doesn't have a lot of sharp edges at all, and they make perfectly beautiful, clear stone. So many public buildings are made out of limestone. Most of the buildings in Washington, D.C., state capitals all over the country are sheathed in limestone, which is a very beautiful, clear, whitish stone. Okay, very easy. The limestone has to have calcium carbonate in it, and that carbonate is coming most of the time from seashells. So a marine organism is going to excrete this shell as it's growing around itself, made out of carbonate. And so that carbonate, when the seashell breaks down and weathers, those minerals that are in that carbonate can come together, and under high pressure at the bottom of the ocean can be squished together into stone. So much of the limestone would have been a marine environment at one time, then later would be laid down as stone. Here's some other examples besides limestone. This is chalk. So this is I believe the White Cliffs of Dover in England, and these are microplankton, which essentially are very small. And as it became the limestone, this wasn't necessarily seashells, but more plankton. You end up with these large calcium, huge pieces of calcium that used to be underwater. Okay, so this cliff at one time was under the sea, and then all of the dead organisms would fall to the bottom and settle, and then leach out, and you end up with a chemical reaction that turns this into stone. So what used to be simply just layers of plankton, dead plankton, the exoskeletons of them became limestone. There's other examples too. So coquina is a rock that has lots of seashells in it, and it's obvious. So little tiny seashells, but yet it's a rock. So it's like a conglomerate, but instead of little round pebbles, you have obvious seashells. You see a lot of that. Chalk, we've already seen, is microscopic plankton. Travertine is limestone that forms in caverns, so where the walls have been eaten away by acid. So we'll talk about caverns and caves later. And then you're going to see other types of rocks like agate, beautiful agate, and jasper, flint, which is hard. They used to use it in muskets. All of that is tiny, tiny, tiny pieces of quartz. Sand also, is quartz, and gypsum can come out of solution too that was dissolved, and this is a positive and negative thing where they find each other and then they settle out as a crystal. And then coal is it's organic, so this is going to have lots of carbon in it. These used to be living things, and they were laid down in huge numbers, so huge amounts of living things died all at once and then was quickly buried. And then as that happened, it pressurized it into coal. And the coal deposits can burn. That's one of the things that hydrocarbons can do. So again, we're looking at size and chemical composition. So the first ones that we're going to look at is calcite. So this calcium carbonate. And calcium carbonate, it depends on what you have. So remember, clastic rocks are made up of little parts of other rocks. So if it's laid down simply by lots of stuff dissolved in the water and then they settle out, then that's non-clastic, okay? So if you have very, very fine and crystally material, you'll have limestone, okay? And you have different types of limestone. So that if you have crystalline limestone, then you have crystalline particles that are settling, then you have crystalline limestone. If you have even smaller particles, it's called microcrystalline limestone, different shape. And then if you have bigger particles, that limestone has a different name. It's called travertine. And travertine is beautiful. You can make floors out of it. Okay. If you have clastic rocks, and if you remember, clastic means it's put together from other little parts that are kind of glued together. Coquina is the one that has obvious little tiny seashells in it. Okay. Fossiferous limestone, you see the word fossil there, is where the material settles down over organisms and shells and things like that, and basically makes an imprint. As that is decaying, you end up with essentially a record, and so lots and lots of fossils in that. We've already looked at the shells and the plankton exoskeletons that can make chalk, and then really, really fine would be called chert. And then the stuff that comes out, gypsum is a mineral with it's a very soft rock that comes out as a crystal. It's called gypsum. And then depending on what other material you have, if you have sodium chloride, then that's salt. And so you have rock salt. And then if you have organic matter, you've got coal. So there's lots of different types of these chemical rocks.